So welcome to this May June 2008 paper S1 of CIE. We shall solve all the questions. He's asking find the median and the quartile. So how many terms are there? 4 plus 6 is 10, 10 plus 9 is 19, 19 plus 7 is 26, plus 5 is 31. So there are 31 terms. So I want Q2. So which is 31 plus 1 by 2, which is the 16th term. So 16th term, I calculate the 16th term, 10 terms are over. So 4 plus 6 is 10, so 11, 12, 13, 14, 15, 16. 16 is 24. So my Q2 is 24. Now calculate the lower quartile. So I came to know the 16th term is Q2. So there are 15 terms on the left side. So the middle term of that one. So 15 plus 1 by 2, which is 8th term. 8th term is going to be my Q1. So what is 8th term? 4 terms, 1, 2, 3, 4, 5, 6, 7, 8. 8 is 16. So 16. So Q1 is equal to 16. So I write over here Q1 is equal to 16 and Q2 just now we got 24. Now he gave interquartile range. Interquartile range is given as 19. Find the value of X. Interquartile range means upper quartile minus lower quartile is equal to 19. Upper quartile we don't know, which is Q3, minus lower quartile is 16 is equal to 19. So upper quartile is equal to 35. So from this 24, 8th term 1, 2, 3, 4, 5, 6, 7, 8. 8th term is 3x. So Q3 is equal to 3x. So implies x is equal to 5. Next, in a country, 30% of the people who drink tea have sugar in it. So, and 65% of the people who drink tea have sugar in it. There are 3 million people in country A, 12 million people in country B. So I draw a tree diagram quickly so it becomes easier. Country A, country B, 3 million people, 3 upon 15, 12 million people, 12 upon 15. Then out of those who drink tea have sugar in it. Sugar, no sugar, sugar is 30%, 30 upon 100, so remaining 70 upon 100. Same is the case, sugar and no sugar, sugar, no sugar. This is 65% of the people, so this is remaining 35% of the people. Find the probability that is chosen from A. Probability of A is just 3 upon 15, which is 0.2. Find the probability that he does not have sugar in tea. No sugar will be 3 upon 15 times 30 upon 100 or 12 upon 15 times 6. No sugar. It is does not have sugar in the tree. So 3 upon 15 times no sugar in A will be 70 upon 100 plus 12 upon 15 times 35 upon 100. So this gives me the answer 0.42. Next, given that does not have sugar in tea. Given that. So whenever it is a given that, write in the denominator. No sugar. That one. So 3 upon 15 times 70 upon 100 plus 12 upon 15 times 35 upon 100. A part of it goes to numerator. Which part? He says that it is from country B. So country B number is this one that goes to the numerator. 12 upon 15 times 35 upon 100. So simplify that, 0.667. Question number 3. Isham has 11 different CDs, of which 6 are pop. Pop are 6, jazz are 3, classical are 2. How many different arrangements are done if all jazz CDs are next to each other? So totally I have 11 units minus all 3 units and all those jazz as 1 unit, jazz as 1 unit. So it becomes 9 units. 9 units can be arranged in 9 factorial times this 3 factorial. 3 jazz in, because 3 are different, so 3 factorial. So 9 factorial times 3 factorial, which will become, this is the answer from the calculator. Isham makes selection of 2 pop CDs, 2 jazz and 1 classical. So how many he chooses? He chooses 2, 2 and 1. 2, 2 and 1. So it becomes 6C2 times 3C2 times 2C1, which is 90. In a certain country, the time taken by a common infection to clear up is normally distributed with mean mu days and standard deviation is 2.6. 25% of this infection clear up in less than 7 days. So probability of x less than 7 is 25%. So convert into z less than 7 minus mu by 2.6 is equal to 0.25. 0.25 is not there in the table, so I have to subtract from 1, so 0.75. In order to nullify this effect, 7 minus mu is written as mu minus 7. So mu minus 7 divided by 2.6 is equal to, check from the table, 0.7674. So from there, mu value is 8.75. In another country, has the same standard deviation, but the mean is 6.5. Find the probability takes longer than 6.2. Mean is 6.5, standard deviation is going to be same 2.6 and greater than 6.2. So convert into z, greater than 6.2 minus 6.5 by 2.6. Probability of z greater than minus 0.1154. From greater to lesser than, 1 minus probability of z less than minus 0.1154. 1 minus probability of z less than 0.1154. So what I have done, if I want to convert negative to greater than to lesser than, I did 1 minus. Next, if at all I want to convert negative to positive, I do 1 minus. So it is probability of z less than 0.1154. 2 times I have done 1 minus, and finally I am going to write it as 0.546. Question number 5, asking us to draw a histogram. So I have to find a new column called as frequency density. I have done it here earlier, so I am just writing it out over here to save the time. Frequency density, 11 divided by 0.5. How I got this 0.5? This difference is 0.5. Next, 15 divided by, the difference is again 0.5. I use different colors so identify. This 0.5 is because of that one. Then 18 divided by, the difference is 1. And next time 30 divided by, the difference is again 1. And finally 21 divided by, the difference is 1.5. That is frequency density. So once I get that frequency density, what am I going to do it is, this is my histogram. So we can draw it out by histogram. And one main thing in an histogram, we have to write it out, the units of this axis, time, and this is frequency density, and this is 0. So draw the histogram. Coming to the next part, calculate the mean. So for mean, I have to calculate the midpoints. So midpoints for this one will be 0.1 plus 0.5 by 2, which is 0.3. For this one, the next one, the midpoint will be 0.6 plus 1 by 2, which is 0.8. For the next one, the midpoint will be 1.1 plus 2.0 by 2, which is 1.55. And the next one, the midpoint will be 2.1 plus 3 divided by 2, which is 2.55. And for the next one, the midpoint will be 3.1 plus 4.5 by 2, which is 3.8. So mean is sigma fx by sigma f, which is 11 times 0.3 plus 15 times 0.8 plus 18 times 1.55 plus 30 times 2.55 plus 21 times 3.8 divided by 11 plus 15 plus 18 plus 30 plus 21, which becomes 199.5 divided by 95, So the mean becomes 2.1 hours. Don't forget to write hours. Question number 6. Every day Eduardo tries to make a phone call to his friend. Every time he phones, there are 50% chance that his friend will answer. If his friend doesn't answer on that day, if his friend answers, Eduardo does not phones again on the day. If his friend doesn't answer, Eduardo tries again in a few minutes time. If his friend does not answer 4 attempts, he will not try on that day again. So we have to draw a tree diagram for that. So first time is answering, not answering. Answering is 1 upon 2, 1 upon 2. Then if he doesn't answer for the first time, then he'll try for the second time. Second time chances are again answers, does not answer, so which is 1 upon 2, 1 upon 2. Then if he doesn't answer, he will try for the third time. Answers, does not answers, 1 upon 2, 1 upon 2. And he'll try for the fourth time. Answers, does not answers, 1 upon 2, 1 upon 2. Done. Next, let x be the number of unanswered calls. Copy and complete the table. I have copied the table. This is unanswered calls. So first time unanswered. So 0 times unanswered. 0 times unanswered means he has already answered it out. First time only. So 1 upon 2. Second time unanswered. 2 unanswered calls. So what does it mean? 2 unanswered calls. So first time, second time, third time. First time is unanswered, second time is unanswered, third time is answered. So it is 1 upon 2, 1 upon 2, 1 upon 2. So it becomes 1 upon 8. Next one is 3 unanswered calls. 3 unanswered calls. There should be 3 unanswered calls. So first time not answered, second time not answered, third time not answered, so fourth time is answered. So this is 1 upon 2, 1 upon 2, 1 upon 2, 1 upon 2. So which becomes 1 upon 16. Next is 4 unanswered calls. So first time, second time, third time, fourth time. This is unanswered, 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 and unanswered. So which is 1 upon 2, 1 upon 2, 1 upon 2, 1 upon 2. Which is again 1 upon 16. So fifth time he is not asking. He is not trying only. So that is a table. Calculated the expected frequency. He is asking expected frequency, expected value of x. So it is sigma xpx. Or just multiply these two and add it out. so it becomes 0 times 1 upon 2 plus 1 times 1 upon 4 plus 2 times 1 upon 8 plus 3 times 1 upon 16 plus 4 times 1 upon 16, which is 15 upon 16, or which is 0.938. Now coming to the last question, 7th question. A die is biased such that the probability of throwing 5 is 0.75 and 1, 2, 3, 4, 5, 6 are equal. 1, 2, 3, 4, 6 are equal. So a die is, so let us draw the table. This is for 1, 2 done, 2, 3 done, 3, 4 done, 4, 5 done, 5, 6 done. So x, probability of capital X is equal to x. So this is 1, 2, 3, 4, 5, 6. For 5 is 0.75 and remaining all are equal, he says. So x, 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 x. We know that sum of all probabilities is 1. So 5x plus 0.75 is equal to 1. 5x is equal to 0.25. X is equal to 0.25 divided by 5, which is 0.05. So each one is 0.05. So erase, 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 and write it as 0.05, 0.05, 0.05, 0.05, 0.05. Now find a probability that it is that the result is 1 is followed by 5 followed by any even number. So 3 times I should get 1, 5 and an even number. Probability of 1 is 0.05. Probability of 5 is 0.75. Probability of even number. What are the even numbers? Even numbers are 2, 4, 6. So it can be 2 or it can be 4 or it can be 6. So multiply all this, because first followed by 1 followed by 5 and even number, and means multiplication or means addition. So let me write it out neatly in detail. So it should be 1 and 5 and even number. Probability of 1 is 0.05 and means multiplication. Probability of 5 0.75 and means multiplication. Even number. Even number, it can be 2 or 4 or 6. So probability of 2 is 0.05 or means addition. 4 0.05 or means addition. 6 0.05. Simplify this, you should be getting the answer 0.00563. Find the probability that out of 10 throws, at least 8 throws result in 5. Probability of at least 8 result in 5 means 8 times 5, 9 times 5 or 10 times 5. So my success is considered as getting 5. So success is 0.75, failure will be 0.25, 1 minus 0.75. So out of 10 times, 8 times success, 2 times failure. Out of 10 times, 9 times success, 1 time failure. Out of 10 times success, 1 time failure, 0 times failure. Simplify this, 0.526. A die is thrown 90 times. Using the approximation, probability that the 5 is thrown more than 60 times. So n is equal to 90. Success is 5, right? So, and q is the failure, 0.25. So find mean NP, which is 90 times 0.75, which is 67.5. Standard deviation is square root of NPQ. 90 times 0.75 times 0.25, which is square root of 16.875. Now it should be greater than 60. So greater than 60 approximation, whenever it is 60, you should take 60.5 minus 67.5 divided by square root of 16.875. So probability of z greater than minus 1.704. So greater to lesser means 1 minus. Then negative to positive means one more time 1 minus. So finally answer 0.956. That completes the paper. See you in the next